All right, pre-calculus 30, proving trigonometric identities, question number 47. All right, so the more complicated side obviously is not just this number 1. There's an infinite number of ways you could transform number 1, right? So we have no clue what to do with just a 1. So we have lots of things that we can see and do on the right side. So that's why you want to pick the more complicated side, really, because there's just a lot more opportunity to know where to go. So again, performing the indicated operation is one of the things you can do. That's usually a good idea. Changing everything into sine and cos can get a little tricky because you're going to have, like, this one's going to be cos over sine. And yes, that's going to simplify up top pretty good, but then you're going to have fractions within fractions. So that can be tricky as well. But we are going to work on the right side, so let's see how that goes. All right, I would perform this operation, so let's do secant theta minus tan theta as a common denominator. And that means I'm going to have to multiply that by the top as well. So I've got sine times cotan. Now what's cotan again? Well, let's should we do that? Yeah, I guess we can. Sine times cotan, because cotan is, where is it? Cos over sine. See that? So sine times cos over sine. So that's going to help us, right? Yes, I've got a fraction inside a fraction, but you can probably handle that. Common denominator, I'll just write it once here. Okay. And over here now, I've got minus. Got to be careful with the minus, because so be careful with the minus. We're subtracting, and then it's multiple terms, so be careful with that. So minus, what's sine times secant? Well, what's secant? That's 1 over cos, right? So I'm going to say minus sine over cos is minus, that's going to be a tan theta. You do this one. And then sine times tan, well, tan we say is sine over cos. Okay. So that's going to be a minus. Well, I guess I've got this bracket here, so leave that minus there. Sine times tan really is sine squared over cos, because it's sine times sine over cos. Okay. All right, we can do lots of simplifying here, so let's start to do that. I'm going to do this, right? So that's going to be just a plain old, I'll turn it to black. It's going to be a plain old cos over here. Oh, whoops, not over anything yet. Minus tan is sine over cos. Okay. And then I'm going to distribute this negative sign. That's going to be a plus sine squared over cos. Okay, everyone see that? Over secant theta minus tan theta. Okay. Well, now that I've got these over cos, it might be a good idea to make this one over cos as well. So cos is the same as cos squared over cos. So now I've got all of this right here in common denominator, so I can simply add up the tops, combine the tops under a common denominator. And actually, if you've watched my other videos, you'll see that if this is going to be a common denominator anyways, it can just go down here, right? It can multiply by this, what's down here already. Now, let's see if I want to do that or not. Maybe. Okay, so cos squared, another thing I'm seeing, cos squared plus sine squared. See that? Cos squared plus sine squared is 1. So that's going to be really 1 minus sine all over cos. Let's just do one step at a time here. Change to blue. So 1 minus sine theta over cos theta all over secant theta minus tan theta. Okay. Now remember, we're trying to get to 1 here. See, we're trying to get to 1, so that can kind of inform you on what we're going to do here. And I know this looks really gross. But hey, if something equals 1, that means the top is the exact same as the bottom. So can I get this top to secant theta minus tan? And maybe you're noticing this, but if I write this minus this, you see what happens? See that? Maybe you don't. Let me show you. What's 1 over cos theta? And what's sine over cos? One over cos is secant theta. Sine over cos is tan theta. Looky, looky. Nice. So that equals 1, which is exactly what we're looking for. I haven't been doing the QED at the end of these proofs, but you should do QED at the end of the proofs. Makes you look sharp, tells everyone you're done, and you know you've got it right. Okay, so that's 47.